This lesson is on vertex form of a quadratic equation. We have already learned what standard form of a quadratic equation looks like. That is y equals ax squared plus bx plus c. This is just an additional way that the quadratic equation can be written. We call it vertex form because we can actually easily see the point of the vertex from the equation itself. So we're going to take a look at that. So vertex form of a quadratic equation is going to look like y equals a times x minus h squared plus k. Okay, I know that looks kind of crazy to you right now, but really what's happening is this a, this h, and this k are potential numbers that could be in place of there. The x and the y are going to stay x and y, and sometimes you just might see a number in a's position, sometimes you might see a number in h, sometimes you might see a number in k. Okay. So from this vertex form, the values h and k are actually the values of the point of the vertex. So h is the x coordinate of the vertex, k is the y coordinate of the vertex. Now you do notice there is a minus in front of the h. That minus is a part of the formula. So whenever I have something in vertex form and I am trying to pull the vertex out of that form, I have to remember that there's originally a minus in the formula, so I'm just taking out the value of x. So the point hk is really the vertex because that's the x and y coordinate of the point of the vertex, but you got to remember to take out the x for what it is. So now if I had a vertex form and it was something, for example, y equals x plus 3 squared minus 4, I have to remember that the original formula here had a minus. So the only reason why there would be a plus here is because the 3 itself is also negative. So when I try to pull out a vertex here, sorry, that minus should be there. When I pull this 3 out, I've got to remember that it's really negative, and the outside value, the y value, it is very easy. It's doing exactly what it's saying. So if it's negative, it stays negative. If it's positive, it stays positive. It's just the inside of the parentheses, this h, which represents the x coordinate, that's the one that we have to be careful of because the original formula has a minus. Another piece of information we can pull from that, we remember that from the vertex, the x coordinate is actually the same thing as the x coordinate in the axis of symmetry. So this is our axis or line of symmetry. So axis of symmetry is just h itself. So once again, if we had a formula and it was y equals x minus 4 squared plus 2, when we're trying to pull out the number for the axis, we've got to remember that it's just this 4 because the minus is a part of the form. So if I were to write the axis of symmetry of this particular quadratic equation, it would just be that x is equal to positive 4. That's the line that's cutting this parabola in half. Again, if it had been a positive number here, I would have had to pull out the negative because I knew that that double negative is what made it positive. So let's try a few examples. So give the axis of symmetry and vertex of each equation. So we have our equation here. I know it's in vertex form because there's only one term here that's squared, and there's a minus 2 outside. So if I wanted to identify a, h, and k, a would be 1, h would be 4, technically a negative 4, and k would be a negative 2. For the axis of symmetry, we remember that that comes from just this x value, which is really called h, but it's representing the x value, the horizontal shift of the graph. But since there's a plus in front of it, I know that that plus came from minus negative 4, so it's really negative 4. So the axis of symmetry is actually going to be an equation. We always got to remember to write x equals because it is a vertical line. So it's going to happen at x equals negative 4. And then we have to also pull out our vertex. So we know that this number inside the parentheses is representing the x value and it switched, and the number outside the parentheses is representing the y value of the coordinate of the vertex. So 4 was really originally a -4, and y is -2. So the point where this graph would change places is at the point -4, -2. All right, number 2, same situation, trying to find the axis of symmetry. So I know that this number here represents the number of the x-coordinate where the line's going to go through. That minus is a part of the form, so I'm only taking out the 3, and I know that the equation for the axis of symmetry is at x equals 3. So taking out the vertex here, that 3 itself is the x-coordinate, and since there's no plus or minus here, there's really like a understood +0, there was no change on y. So the actual point of the vertex is +3, 0. So if you don't have any plus or minus outside of the parentheses, that means there was no change vertically. It didn't go up or down. So the y-coordinate remains a 0, so it would be +0. Number 3, I'm actually going to let you try on your own. So I'm going to let you keep that one on your own. And on number 4, this one is actually not in vertex form, but we should still know how to find the axis of symmetry and the vertex from this form. This is technically standard form. We just do not have a middle term, but this is standard form. So reminding you how to find this information from standard form. To get the axis of symmetry, we had a formula, -b/2a. That helps us find the axis of symmetry. In this particular problem, there is no b in the middle because it was a 0 term, which is why I do not have an x to the first power. It's really like -2x squared plus 0x plus 3. So -2 is a, 0 is b, 3 is c. So I'd have -0 over 2 times -2, which is just 0 over -4, which is 0. So I know the axis of symmetry is x equals 0. The vertex, when we didn't have it in vertex form, we found the vertex by using the x-coordinate from the axis of symmetry and plugging it into the original equation, inputting the x to get a y value so we can find our ordered pair. So we already know that 0 is the x-coordinate of the vertex. When we plug it in, y is equal to -2 times 0 squared plus 3. 0 squared, 0. 0 times -2, 0. And then 0 plus 3 is 3. So our y-coordinate of the vertex is a +3. So with vertex form, it's a lot easier to just pull out the vertex, and we already know the axis of symmetry happens at the x-coordinate of the vertex. If it's not in vertex form, we have to use that formula we learned and do a little bit extra work. So number 3 is one that I want you to try on your own. We're going to move to the next section. So in this next section, we're going to look at graphing from vertex form. So we already did a little bit of graphing from standard form. Now we're going to see how we could do it if the equation was in vertex form. So it says graph each equation using a table of values, identify the axis of symmetry, vertex, domain, and range. Okay, so this one is in vertex form. So I personally think it's going to be a lot easier because I can see information from the equation itself. So I already know that this number inside the parentheses is representing the x-coordinate of the vertex, and this number outside is representing the y-coordinate of the vertex. And I also know that this number tells me my axis of symmetry. But I got to remember that the original form has a minus between the x and the other number, so that 2 must have originally been negative. So now the equation for the axis of symmetry is x equals -2. The vertex is happening at -2, comma. The outside's just easy. It does what it says. It is a +7. So to graph, we do know our vertex is at the point -2, 7. So -2, 1, 2, 3, 4, 5, 6, 7. I'm going to go ahead and put my vertex there. The axis of symmetry is happening at x equals -2, so I'm going to draw this little dashed line here to remind myself that's the axis of symmetry. Okay, so we have a couple different options. We can do what we did last time. I can put the vertex in the middle and then pick some points on either side. I could pick the vertex and put it in there and put just a couple points, then reflect it on the other side of the axis. I'll go with the first way we did it just because that's probably what we're comfortable with at this point. So I'm going to put the vertex -2, 7 in the middle of the table. I'm going to pick some x values to the left of the line and to the right of the line. So I'll use this starting from the origin, I'll use the point -3 and -4. So I'm going to put in -4 and -3 for x to find out. And then I'm also going to do some to the right of this line of symmetry. So I'll do one at 0 and at -1. So -1 and 0. I picked those points because I started with this line of symmetry and I went to the left of it and to the right of it with some x values so that I can substitute in and find some y values. So if I start with -4, in order to figure out what the matching y to that point is going to be, I've got to substitute it in. Now this is if I'm doing it by hand. So I've got y equals negative, in parentheses, -4 plus 2 squared plus 7. Remembering order of operations here, I've got negative. Inside the parentheses, we're going to have -4 plus 2, which is a -2 squared plus 7. -2 squared comes out to be +4, but there's the negative outside, so it's -4 plus 7, which gives us a 3. I'm going to repeat this process with the remaining x values. 6, 7, 6, 3. I went ahead and did that not to bore you out of your mind by working all of those, but if I just continue to input, I would get the output that matches. Now I need to plot these points to draw my parabola. I've got -4, 3, 1, 2, 3, that's a point. And I've got -3, 6, so -3, 1, 2, 3, 4, 5, 6. We already know our vertex. -1, 6, and 0, 3. We need to make a smooth curve. Try and make it look like a parabola. All right. And now we need to write our domain and range. So here we need to have a little bit of a conversation of a couple different ways you might see domain and range. So we've already talked about it one way in interval notation. We remember domain represents the x values, reading it from left to right. So for all parabolas that are functions, it's really going to continue to be from negative to positive infinity. And if we wrote it the way we've already been writing it, I got to remember it goes in parentheses and it's negative to positive infinity. So that's the way we've been doing it. Because it's going infinity both ways, another way you might see it written is all real numbers. It's like a double L, double line, and then an R over it. That just means all real numbers. It means infinity both ways, basically. Okay. For your range, we were reading the y values from the bottom to the top. So if I start on the bottom thinking what is the lowest y value, well, it's going to keep going down forever. So it starts out at negative infinity, and then it's going to go up to a certain point, a stopping point. So this particular point here, this is our maximum. Our max value here is the y value of 7. So I would have comma 7, and since 7's a part of the graph, it's included, it gets a bracket. Okay, so that's one way that we've been doing it. You might also see it written a different way. Okay, they also tend to write it with inequalities sometimes. So for domain, they could have written negative infinity is less than x, which is less than positive infinity. Or on here, they could have said y is greater than, y is less than or equal to 7. So when they're writing it with these inequality symbols, this first one is saying that x exists, the domain exists between all negative and positive infinity values. Now the reason I didn't put an equal under there is the same reason why I didn't put a bracket around them. Infinity cannot be included. It's a concept, not a specific number. The reason why this one is written this way is because if you think of a number line, if I was trying to say on on a number line, if I was given this notation and I had from negative infinity to 7, well, that would be telling me that this goes up to a closed-in circle at 7, and the arrow would be pointing everything down that way. Well, what this is saying is that all the y values on this graph exist for everything less than or equal to 7. So it can be anything below 7, it can be 7 itself, but we can't have any y values above it. So those are a couple different ways you might see domain and range written. For this particular part of the lesson, there is one last piece, and I want you to try number 6 on your own. So far from this first lesson, you have numbers 3 and 6 to be trying on your own.